Diesel fuel is not explicitly classified in the National Electrical Code, or NEC. However, it falls under the broader category of Class 3 liquids as defined in Article 500. Article 501.4. A7 of the NEC states that electrical installations in the vicinity of Class 3 flammable liquids shall be made in accordance with the general requirements of Chapters 1 through 4. When dealing with a diesel tank inside a building with a concrete dike for spillage, with the conduit running below the diesel tank raised above the dike, several principles should be considered. Firstly, minimize ignition sources. Conduit and wiring should be installed in a manner that minimizes the possibility of igniting any flammable liquids. Secondly, maintain separation. There should be adequate distance between the conduit and any potential sources of ignition, such as the diesel tank or other equipment. Thirdly, provide adequate ventilation. The area where the conduit is installed should be well ventilated to prevent the accumulation of flammable vapors. It is recommended that you consult with a qualified electrical inspector. They can assess the specific conditions of your project and provide guidance on compliance with NEC requirements. Install conduit in a separate raceway or enclosure. This will provide additional protection from potential ignition sources. Utilize explosion-proof or intrinsically safe equipment. If the conduit passes within a hazardous area, such as near the diesel tank, explosion-proof or intrinsically safe equipment should be used. Ensure proper bonding and grounding. All conduit and equipment should be properly bonded and grounded to prevent static electricity discharge. By following these recommendations, you can help ensure the safety of your electrical installation in the vicinity of the diesel tank. It's important to consult the relevant NEC articles to ensure full compliance with all applicable requirements. The National Electrical Code, or NEC, provides guidelines for electrical installations in various environments, including those where flammable liquids are present. While diesel fuel isn't explicitly classified, it falls under the category of Class 3 liquids, which have specific requirements outlined in the NEC. When installing electrical conduit near a diesel tank, safety should be the top priority. Here's a breakdown of the key considerations. Firstly, understanding Class 3 liquids. Class 3 liquids, as defined by the NEC, are flammable liquids with a flash point at or above 100 degrees Fahrenheit, such as diesel fuel. Article 500 of the NEC covers the requirements for electrical equipment and wiring in hazardous locations, including those where Class 3 liquids are present. Secondly, NEC requirements. Article 501.4. A7 of the NEC stipulates that electrical installations in the vicinity of Class 3 flammable liquids must comply with the general requirements of Chapters 1 through 4 of the NEC. This means that standard wiring methods, overcurrent protection, and grounding practices apply. Thirdly, specific considerations for diesel tank installations. When installing conduit near a diesel tank, there are several factors to keep in mind. Minimize ignition sources. Ensure that all electrical equipment and wiring are installed in a way that minimizes the risk of ignition. This includes using appropriate enclosures, sealing fittings, and preventing sparks or arcs. Maintain adequate separation. Keep a safe distance between the conduit and any potential sources of ignition, such as the diesel tank itself or other equipment that could generate heat or sparks. Provide proper ventilation. Ensure that the area where the conduit is installed is well ventilated to prevent the accumulation of flammable vapors. Install conduit in a separate raceway or enclosure. This provides an extra layer of protection against potential ignition sources. Use explosion-proof or intrinsically safe equipment in hazardous locations, such as near the diesel tank. It may be necessary to use explosion-proof or intrinsically safe equipment to prevent ignition. Ensure proper bonding and grounding. All conduit and equipment must be properly bonded and grounded to prevent static electricity discharge, which can be a source of ignition. And finally, consult with a qualified electrical inspector. It's always best to consult with a qualified electrical inspector who can assess the specific conditions of your project and provide guidance on compliance with NEC requirements. In summary, installing electrical conduit near a diesel tank requires careful consideration of the NEC guidelines for Class 3 liquids. By minimizing ignition sources, maintaining adequate separation, providing proper ventilation, and following other safety measures, you can help ensure a safe electrical installation. Here's a more in-depth look at each of these considerations. Firstly, minimizing ignition sources. Ignition sources are anything that can provide enough energy to ignite flammable vapors. Common ignition sources include sparks, arcs, hot surfaces, and static electricity. To minimize ignition sources, the following measures should be taken. Use appropriate enclosures. Electrical equipment and wiring should be installed in enclosures that are designed to prevent sparks or arcs from escaping and igniting flammable vapors. Ceiling fittings. Ceiling fittings should be used to prevent flammable vapors from entering electrical enclosures. Prevent sparks or arcs. Avoid using electrical equipment that can generate sparks or arcs in hazardous locations. Secondly, maintaining adequate separation. Maintaining adequate separation between electrical equipment and potential ignition sources is crucial for preventing fires or explosions. The NEC provides specific guidelines for separation distances in hazardous locations. These distances vary depending on the type of hazard and the class of liquid. Thirdly, providing proper ventilation. Proper ventilation is essential for preventing the accumulation of flammable vapors. Ventilation can be achieved through natural or mechanical means. Natural ventilation relies on the movement of air through open windows or doors. Mechanical ventilation uses fans to circulate air. Fourthly, installing conduit in a separate raceway or enclosure. Installing conduit in a separate raceway or enclosure provides an extra layer of protection against potential ignition sources. This is especially important in hazardous locations where there is a high risk of flammable vapors being present. Fifthly, using explosion-proof or intrinsically safe equipment. Explosion-proof equipment is designed to contain an explosion within the enclosure, preventing it from spreading to the surrounding environment. Intrinsically safe equipment is designed to operate at low voltage and current levels, which are not capable of igniting flammable vapors. Sixthly, ensuring proper bonding and grounding. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. Grounding is the process of connecting the electrical system to the earth. Proper bonding and grounding are essential for preventing static electricity discharge, which can be a source of ignition. By following these recommendations, you can help ensure the safety of your electrical installation in the vicinity of the diesel tank. Always consult the relevant NEC articles and a qualified electrical inspector to ensure full compliance with all applicable requirements. When considering the installation of electrical conduit in proximity to a diesel tank, several factors come into play, primarily dictated by the National Electrical Code, or NEC. While diesel fuel itself isn't directly classified, it falls under the broader category of Class 3 liquids, influencing how electrical installations must be handled. This situation presents unique challenges that necessitate careful planning and adherence to safety standards. The NEC serves as the cornerstone for safe electrical practices, especially in environments with potential hazard. Article 500, which pertains to hazardous locations, becomes particularly relevant here. Even though diesel fuel isn't as volatile as gasoline, it's still a flammable liquid, and its presence warrants precautions. Understanding Class 3 liquids is fundamental. These are flammable liquids that have a flash point at or above 100 degrees Fahrenheit. This characteristic means that, under certain conditions, diesel fuel can release vapors that could ignite. Therefore, it's essential to minimize any potential ignition sources in the vicinity. The NEC mandates that electrical installations near Class 3 liquids adhere to the general requirements outlined in Chapters 1 through 4. This covers a wide range of aspects, including wiring methods, overcurrent protection, grounding, and bonding. In practical terms, this means that the materials and methods used for the conduit installation must be suitable for the environment. Considerations for the specific scenario with the diesel tank inside a building, the concrete dike, and the conduit running below the raised tank require a multifaceted approach. Firstly, minimizing ignition sources is paramount. The goal is to prevent any electrical equipment or wiring from becoming a source of ignition. This involves using enclosures that can contain sparks or arcs, sealing fittings to prevent vapor ingress, and avoiding any equipment that could generate high temperatures. Secondly, maintaining adequate separation is crucial. A sufficient distance must be maintained between the conduit and the diesel tank, as well as any other equipment that could pose an ignition risk. The NEC provides guidelines on minimum separation distances in hazardous locations, and these should be strictly followed. Thirdly, proper ventilation plays a vital role. Ensuring adequate ventilation in the area can prevent the accumulation of flammable vapors. This can be achieved through natural ventilation, such as open windows or doors, or through mechanical ventilation systems that actively circulate air. Fourthly, using a separate raceway or enclosure for the conduit can provide an additional layer of protection. This can help to isolate the electrical wiring from the surrounding environment and reduce the risk of ignition. Fifthly, explosion-proof or intrinsically safe equipment may be necessary in certain situations. If the conduit runs through an area where flammable vapors are likely to be present, using equipment designed to prevent explosions or operate at inherently safe levels of energy is essential. Finally, proper bonding and grounding are critical for preventing static electricity discharge. Static electricity can be a source of ignition, so ensuring that all metal parts of the electrical system are properly bonded and grounded is crucial for safety. To ensure compliance and safety, consulting with a qualified electrical inspector is highly recommended. An inspector can assess the specific conditions of the project, provide guidance on NEC requirements, and help to identify any potential hazards. This is particularly important in situations where the NEC may not provide explicit guidance on a specific scenario. The inspector's expertise can help to ensure that the installation meets all applicable safety standards. In summary, installing an electrical conduit near a diesel tank requires a thorough understanding of the NEC, particularly the requirements for Class 3 liquids and hazardous locations. By minimizing ignition sources, maintaining adequate separation, providing proper ventilation, using appropriate equipment, and consulting with a qualified inspector, it's possible to ensure a safe and compliant installation. The primary goal is to mitigate the risk of fire or explosion by preventing any electrical equipment or wiring from becoming an ignition source. This requires a proactive and comprehensive approach that considers all potential hazards and implements appropriate safety measures. The diesel fuel tank's environment introduces potential risks that demand diligent adherence to electrical safety standards. When installing electrical conduits in such proximity, there are several critical considerations. Primarily, the NEC provides essential guidelines for dealing with potentially hazardous environments, even if diesel fuel doesn't have a specific classification. The key is to understand the characteristics of diesel fuel and how it relates to the NEC broader categories. Diesel fuel is generally categorized as a Class 3 liquid. This classification is due to its flash point, which is the lowest temperature at which it can form an ignitable mixture in air. Understanding this classification is crucial because it dictates the types of electrical equipment and wiring methods that are permissible in the area surrounding the tank. The NEC provides specific guidelines for electrical installations in areas where flammable liquids are present, and these guidelines are designed to minimize the risk of ignition. Minimizing potential ignition sources is paramount. This means carefully selecting and installing electrical components that are designed to prevent sparks, arcs, or excessive heat. For example, using sealed or explosion-proof enclosures can help to contain any potential ignition within the enclosure. The choice of wiring methods is also critical. The NEC specifies the types of wiring that are suitable for hazardous locations, and it's important to choose wiring that is resistant to damage and degradation from exposure to fuel or other chemicals. The routing of conduits is also important. The conduit should be installed in a way that minimizes the risk of physical damage or exposure to fuel spills. Adequate support and protection should be provided to prevent the conduits from becoming damaged or dislodged. Adequate separation from the diesel tank is another critical consideration. The NEC may specify minimum separation distances between electrical equipment and fuel tanks. These distances are designed to provide a buffer zone that reduces the risk of ignition. Proper ventilation can help to prevent the accumulation of flammable vapors. If the area surrounding the diesel tank is poorly ventilated, flammable vapors could build up and create a hazardous condition. Ventilation can be achieved through natural means such as open windows or vents, or through mechanical means such as fans or blowers. Regular inspection and maintenance of the electrical system are essential for ensuring continued safety. The system should be inspected periodically to check for any signs of damage, wear, or corrosion. Any problems should be addressed promptly to prevent them from escalating into safety hazards. If the area around a diesel tank is classified as a hazardous location, explosion-proof equipment may be required. Explosion-proof equipment is designed to contain any potential explosions within the equipment itself, preventing them from spreading to the surrounding environment. This type of equipment is typically used in areas where flammable vapors are likely to be present. The NEC also provides guidance on grounding and bonding requirements for electrical systems in hazardous locations. Proper grounding and bonding can help to prevent static electricity buildup, which can be a source of ignition. Consulting with a qualified electrical engineer or inspector can help to ensure that the electrical system is installed in accordance with all applicable codes and standards. An engineer or inspector can assess the specific conditions of the installation and provide guidance on the best way to minimize the risk of fire or explosion. In summary, installing electrical conduits near a diesel fuel tank requires careful attention to detail and a thorough understanding of the NEC and other applicable codes and standards. By minimizing potential ignition sources, providing adequate separation, ensuring proper ventilation, and conducting regular inspections and maintenance, it's possible to create a safe and reliable electrical system in this type of environment. The key is to be proactive and to take all necessary precautions to prevent fires or explosions.